Hello, my name is Steve Bowler, and in this video we're going to be taking a look at BGP, or Border Gateway Protocol. Specifically within BGP we're going to be taking a look at a feature known as the BGP Peer Groups, and we're also going to explain how we configure peer groups, how we verify the configuration, and what we use peer grouping for. In this situation here, we're going to have four routers: router 1, router 2, router 3, and router 4. And this is going to be a configuration of these four routers. They're all going to be peered to each other. So we're going to have a full mesh here. And what I'm going to do is show you how you can use BGP peer groups to simplify your configuration. Specifically, in this case, we're going to be taking a look at how BGP peer groups will drastically improve our configuration to all of our peers. So what peer groups allow us to do is to minimize CPU resources within BGP, because we all know once we enable BGP on our router, and if you're using GNS3, it can be a CPU hog. And so what we can do here is we can create what's called the BGP peer group, which will allow us to simplify our BGP configuration to our peers, and will also allow us to reduce the CPU utilization on our routers. So let's go ahead and get started here. What I'll do is I'll go ahead and set up the topology. I'll just pause the video for a second, and then I'll come back here. As you can see, we're going to we'll just make it easy. We'll just put all these routers in the 172.16.0.0/24 network. Give them all the IP. Router 1's .1, router 2's .2, router 3 is .3, and router 4 is going to be .4. And of course, all these routers we're going to be they're all going to have loopback 0 interfaces. Router 1's is 1.1.1.1, and so on. And what we're going to be doing here is we're going to be doing an internal BGP implementation of BGP peer groups. So what I'm going to be showing you here is how you can simplify your BGP configuration using peer groups. You can put a lot of the commands into a peer group and then just put one command under each neighbor statement to all of your peers. So I'm going to go ahead and pause the video now, and then I'll come back and then we'll go ahead and jump into it. Okay, so I'm back here. I've just configured all the routers, basic interface, and I also went ahead and configured OSPF is going to be our interior gateway protocol between all the routers. So we need to advertise these loopbacks into OSPF and have all the routers have full reachability so that we can peer. What we're going to do here, we're going to have the AS here is going to be just 100. So what we'll do is we'll do a iBGP implementation here. All the routers are going to have this is going to be a full mesh between all the routers, and we'll just show you how to set this up as easily as possible using BGP peer groups. So if we go to router 1, if I do a show IP route, as you can see we have reachability now to all of the hosts. So if we just try to ping like router 4's physical interface, and then we just try to ping like router 3's loopback, as you see we have reachability. So what we can do now is we can go ahead and get onto our BGP configuration here. So on router 1, we'll just get into global config, and then we'll just do a router BGP 100 to start the BGP process for AS 100. And what we're going to do first here is we're going to put in our iBGP configuration here. I'm sorry, not our iBGP configuration, but we're going to put in our BGP peer group configuration, and then we'll apply the peer group to all of our neighbors. So router 1 is going to be peering with router 2, router 3, and router 4. So what we'll do on router 1 first, we will use the neighbor command, and then what we're going to be using here for a peer group is the neighbor tag. So in this case, this is a iBGP implementation of peer groups, so we'll just name it iBGP. So that's what our peer group is going to be called, and then we'll follow that up here with the peer group statement here. So neighbor iBGP, then peer group, and then as you can see here from our options, the peer group option is to configure a peer group. So we'll go ahead and hit enter there. And now that I have the peer group named, and our peer group name again is iBGP, what we can do now is we can apply BGP commands to this name. So for instance here, what we'll do is we'll put all the commands that we regularly, if we were to peer with router 2, router 3, and router 4, we would at least need a neighbor statement containing the remote autonomous system, right? So what we'll do is we'll do neighbor iBGP, and then we'll do remote AS as 100. Again, internal BGP. If you're not familiar with it, you're peering with the same within the same AS. External BGP, you're going to be peering with a different AS as your own. So here we're going to be doing neighbor, and then instead of an actual IP address, as you see here, we're specifying our BGP peer group name, which is iBGP, which is what we implemented here with our first command, given it the peer group option. So we'll do neighbor iBGP remote AS 100, and we'll go ahead and hit enter here. And then as you can see, we can just keep adding options under our peer group. So instead of having to specify all these commands to each neighbor specifically with the neighbor's IP address, we can specify it under the peer group name and then apply the peer group name to the neighbor that we want to peer with. And I'll show you that in just 1 second. But let's go ahead and finish our iBGP options here. I'm sorry, our peer group options here. So we've specified the remote AS of 100. Again, that's going to be for all of these 3 peers of router 1, router 2, router 3, router 4. Router 1 is going to be peering with router 2, router 3, and router 4. So it's going to be peering with all those routers within AS 100. That's why we chose this command. Also, BGP best practice is to, send updates to a loopback interface, because as we all know, a loopback interface will never go down, and it's not ever going to drop unless we delete the loopback interface from the router. So best practices is to peer BGP to your loopback interfaces. So what we'll do here is we'll specify the command neighbor IBGP update source and then loopback 0. So that's saying to all of the whoever I peer with within this peer group, we're going to just say, hey, our update source is going to be loopback 0. Also here within your peer group, within your IBGP peer group, you might want to also have a password to protect it. So we'll just go ahead and put the password as Cisco, or better yet, CCIE. And then what we'll do here, we'll just do one last command. We'll just do a neighbor IBGP, and then we'll just do, say you're tagging neighbors with community tags, or setting communities within your BGP autonomous system. What we can do here is we can do the neighbor IBGP send community option. So we're going to be sending all of our community information to our neighbors that we peer with. Okay, so that should be enough for our basic peer group implementation. As you can see here, we have 1, 2, 3, 4 commands. And again, if we have 3 neighbors here from router 1, so if we were to put all of these commands under each neighbor, if we're running a full mesh, that's going to be 12 commands that we're going to have to specify, within our router configuration. And this is a very small implementation of IBGP. A lot of service providers, there's a lot of companies out there running huge networks, so their IBGP configuration would be maybe 100 times this or greater. So we're just showing you a very small example of how this might be an advantage for your implementation of BGP. But as you can see here, 12 commands we can simplify down to maybe half of that. And what I'm going to show you here is exactly how many commands we'll be simplifying our configuration with. So now what we need to do is we need to peer with our neighbors here. So again, to peer with router 2, we're going to be doing neighbor 2.2.2.2, and then our command here is going to be peer group, and then the peer group name. So again, here our peer group name is IBGP, so go ahead and just specify that. Right, now, and that's it. That's all we need to do. Just doing this command here for router 2, every command that's under this peer group IBGP will be applied to that neighbor. So we don't have to go under the neighbor and do a send community. We don't have to do a password CCIE. We don't have to do the update source loopback 0, and we don't have to do the remote AS100. All we have to do is specify the neighbor IP address and then the peer group we want to put them in. And then they will inherit all of the commands that are underneath that specific peer group. As you can see here, we're getting MD5 authentication errors. Let's go ahead and continue. So let's do neighbor 3.3.3.3, and then peer group IBGP, and then enter. And then neighbor 4.4.4.4, peer group IBGP, and enter. And that's it. So that's our whole BGP configuration. And basically that was how many commands? Let's count them from the beginning. We have 1, 2, 3, 4, 5, 6, 7, 8 commands. So as you can see here, 8 commands, whereas if we weren't doing peer groups between these routers, we'd be running 12 commands on each router. So we've cut the amount of commands down by about a fourth. And again, like I said, this is a very small implementation of peer groups, so you can cut the configuration down drastically, more than a fourth. But that's all it did in this example. Also, again, not only is it cutting down in your the actual configuration that you have to do of your neighbors, your peers, but it's also going to cut down on your CPU utilization on your router, because your updates are only going to be going out once instead of multiple times here. Okay, so let's go to the other routers and we'll go ahead and configure them real fast. So router 2, what we'll do is we'll do a router BGP 100, then we'll do a neighbor. Again, we're going to create our peer group first, which is IBGP, and then we're going to specify that as a peer group. Now we're going to do neighbor IBGP, and then we're going to just specify all the commands we want to put under the peer group. So neighbor IBGP remote AS100, neighbor IBGP send community, neighbor IBGP password CCIE, and then neighbor IBGP. Oh, let's see, what was the other one? Update source is the last one here. Update source loopback 0. And now what we need to do, now that we have our peer group configuration here, now we just go here and do a neighbor and then specify our neighbors. So for router 2 full mesh, we're going to be peering with 1, 3, and 4. So neighbor 1.1.1.1. Again, we're peering with the loopback IPs. That's why we're doing the update source loopback 0 command under the peer group. Neighbor 1.1.1.1, and then all we have to do here is configure, put in the peer group that they're going to be a part of, so IBGP. So neighbor 3.3.3.3, peer group IBGP, and then neighbor 4.4.4.4, peer group IBGP. And that should be it. So what we should see here in a second is we should see the BGP peer come up for router 1. Momentarily. And there we have our BGP neighbor is up now for router 1. Again, we can verify this if we just do a show IP BGP summary. And we see here that we have, peered with router 1. Oops. Right here. So we're good to go. So let's go ahead on router 3. As you can see here, it's drastically simplified the configuration. All we do is go under BGP, we do a neighbor, then we specify our peer group name, which is IBGP, specified as a peer group. then we do neighbor IBGP, then we do our all the commands we want under the peer group. So we're going to configure the remote AS. We're going to configure the update source as loopback 0. We're going to be configuring a password. So we have simple. So we have simple, or we have authentication here between our IBGP peers, and then here we're going to do the last thing here, which is send community information throughout our AS. Now that we have all the peer group commands, what we're going to do now is just configure our neighbors. So router 3 is going to peer to, for a full mesh, router 3 is going to be peering with router 2, 1, and 4. So we put all those loopbacks, and then we specify their peer group association, which is going to be IBGP. And that should be it for router 3. Okay, so now that we have router 3 configured, if we just do a show IP BGP summary, as you can see here, now we're neighbors with router 1 and 2. So let's go to router 4 and set up router 4's peer group configuration. Again, BGP AS 100. We're going to do a neighbor IBGP, which is going to be our peer group name. And then we will follow that up with our peer group commands here. So remote AS 100, update source loopback 0, password CCIE, and then send community. Now that our peer group configuration is set up on router 4, what we'll do, we'll just go ahead and do a, from router 4's perspective here, we need to peer with router 3, 2, and 1. So start with router 1. Again, the command to put the neighbor into a peer group is going to be neighbor, then their IP address, and follow that up with peer group, and then the peer group name, which is IBGP. So now that router 1's done, let's go on to router 2. And I'm sorry, neighbor, yeah, router 2, and then router 3 here. Alright, so that is it. So now we just wait for BGP to form its adjacencies. As you can see there, we're appearing now with router 1, and router 2 just came up. We're just waiting on our last peer, which would be router 3. And there we have it. Our peer group implementation via an IBGP full mesh is now complete. So now on router 4, if I just do a show IP BGP summary, you can see here now that we're peering with router 1, 2, and 3 now. And we've been up for about half a minute with each neighbor. And to verify that our neighbor is actually in a peer group, if you do a show IP BGP neighbor, and then we can see here BGP neighbor for router 1, and what we can see here now is this statement here that says member of peer group IBGP. So that is telling us that for this neighbor we are implementing the peer group IBGP. Again, here now we can see our neighbor statement for router 2. Again, member of peer group IBGP. And last but not least, here with router 3, we're seeing that it is also a member of peer group IBGP. To verify our configuration, we do a show run pipe to begin BGP. What we're seeing here, these first 5 statements, is our peer group that we created. Again, the neighbor, the peer group name is this first command here, neighbor IBGP. This is where we are saying that IBGP is the peer group name. And then for every command that we want to apply to this peer group IBGP, we just simply specify IBGP as the neighbor, and then whatever command we want to follow. So we put all of our, we put IBGP peer group in remote AS100, we gave it a password, we gave it an update source, and we are sending community information to all of our neighbors inside of the peer group. And then our last statement here that we did is to actually put our neighbors into the peer group. So from router 4's perspective, we peered with neighbor 1, 2, and 3, and we put them all into peer group IBGP. So to recap the purpose and the reason why we would use a peer group is that A, it simplifies our BGP configuration, especially when you have multiple BGP peers that you are using similar configuration sets with. So in this case, we have 4 configuration settings that we are applying to all 3 of our neighbors. Again, if you have hundreds of BGP peers that you're running the same commands to, might as well put them in a peer group. That way you only have to do 1 command for the neighbor instead of having to do 4 in this case for every neighbor. And the second reason would be because it it lessens the CPU utilization on the router, so we're sending updates just to the peer group rather than sending it multiple updates. So we have basically two main goals in which we achieve when we use a BGP peer group. Again, I just want to thank you guys for watching this video. This is a BGP peer group basic lab video that I created for you guys. So I hope you guys have enjoyed the video, and I hope you'll be with me with the next one. Thanks.